Okay, now, we used the chip model, so now we're going to look at the charged field model. Now, with the other one that we had, we actually used little chips. And for this one, we're just going to model this by actually drawing it on paper. Okay, without having to actually manipulate anything. So let's start out with the problem 5 plus 2. So charged field model means that I have 5 pluses or 5 positives, and then I have 2 more positives. So I have a total of 7 positives. Which equals 7 or positive 7. Okay? Negative 2 and positive 5. Alright, so let's just model this. I'm going to take negative 2. Okay, and to that I'm going to add 5 positives. 1, 2, 3, 4, 5. Alright, now I'm going to remove my 0 pairs. So I'm going to circle them, and then I'm going to remove them, so that I have left 1, 2, 3 positives. So my answer is positive 3 or 3. Okay? Alright, so let's model negative 7 plus 3. So I have 7 negatives. And then to that, I'm going to add 3 positives. Okay? Now, I have different charge signs. And just like the chip model, I can't have negatives and positives both. I have to have one or the other, so we'll get rid of 0 pairs. And just get rid of those then. And so we're left with 4 negatives. Okay? Now, let's take a look at subtraction with charged fields. Okay, negative 3 minus 8. So I'm going to take negative 3, and I want to take away negative 8. Okay, I don't have negative 8, so I need 8 negatives. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8. Alright, now, I'm going to draw my little line here so you can see this difference. Okay, but I don't have negative 3 anymore, do I? So now I have to account for this with 0 pairs, because I can't make this something other than negative 3 to begin with. So now I have all of this is the same thing as negative 3, because these are all 0 pairs. Okay? Now, I want to take away 8. Okay? Now, I've got negative 8, but I don't have positive 8. So I need some more positives here, don't I? So I've got 1, 2, 3, 4, 5. I can't take away 8 of them, so I have to add 8 of those. 6, 7, 8. So I need some more negatives here, because they all have to be 0 pairs. Okay? So you see why. This says negative 3, take away 8. And I don't have positive 8. I had to go ahead and add some more to give me positive 8. Now these are all 0 pairs, but I added 0 pairs here. So now I have to be able to take away 8. So if I take away 8, that's getting rid of these. So I'm just going to put an X through them. And then I'm left with all of these negatives. And if I count those up, I have 8, 9, 10, 11 negatives. So that negative 3 minus 8 is negative 11. Okay? Now I could have negative 2 minus negative 4. Okay, so let's start out with negative 2. And I need to take away negative 4, but I don't have negative 4. I have to have 2 more. So I'm just going to draw my little line there. So I need 2 more negatives to be able to take away -4. But that means that I have to add 0 pairs. So I have to add all of that. Now, if I take away -4, that would take away all of those. So I'm left with +2. Now, keep in mind your sign rules say these two make that a positive. So -2, +4, signs are different. Subtract and get 2, and it's positive. Okay. Now, let's do 2 minus -5. Okay, so we'll start out with 2, and that's +2. Now I need to take away -5, but guess what? I don't even have any negatives. So I need 5 negatives. 1, 2, 3, 4, 5. But in order to do that, I also need 0 pairs. Because I can't just add 5 negatives. I have to add it in the form of zeros. Alright, now, my problem says I've got +2 here. Now I need to take away -5. So this is -5, so I'm taking them away, and I'm left with 5, and 2 more is 7. +7. So remember your rules here. That would become a +5, so that's 2 plus 5, which is 7. Okay, so the charge field model works very similarly then to the chip model.